Okay, good day everyone. We're back again after the short holiday break we actually proceeded for, and I'm delighted to have you back again for our special maths classes. I want to believe that everybody actually enjoyed the holidays. From us here, we want to wish everyone the compliments of the season, and don't forget, we always have something very important to talk about in maths every time we're here. Today, we're going to be talking about a very interesting topic, the topic we had earlier discussed in our previous video for those of us who have been following us very keenly. We have solution of quadratic equations by factorization method. Don't forget, in our previous videos, we have talked about the types of methods of solving quadratic equation. We mentioned the solution of quadratic equation by almighty formula. We talked about the factorization method. We talked about completing the square and then the graphical method. We took our time in one of our videos to actually discuss extensively on how to solve a quadratic equation using almighty formula. Today, we will delve into the method called factorization method. And it's a method that many students actually find very tricky. They don't always love using the factorization method to solve quadratic equations. And it's simply because of some of the key techniques associated with it. But today we're going to make sure we dissolve it and dissect them very well, so it can be very easy for use. The lesson objectives for this lesson have been outlined below. The first thing, we will just get into it. We have a number of things to actually tidy up. So we'll just run along with it. Meaning of factors. And then HCF. Factors. What are factors? When we talk about the factors of a number, we are talking about finding values that will divide a number without a remainder. Take for instance, values that will divide a number. We're going to be very fast. Values that will divide a number without a remainder. That's what we call the factors of a number. For example, if we are asked to find the factors of 6, now this is a factor of a number, you look for those values that will divide 6 without a remainder. And what are those values? 1 can divide 6, 2 can divide 6, 3 can divide 6, and 6 can also go into 6. So these are referred to as factors of 6. Invariably, we can also look at factors as finding two values you multiply together to get a number. Finding two values to be multiplied. Finding two values to be multiplied to get a number. So if I ask you now, give me the factors of 6, and you do not want to think through the process of finding numbers that you're going to use to divide the 6, you can actually find any two numbers you can use to multiply together to get 6. 1 times 6 will give us 6. 2 times 3 will also give us 6. So you see that the factors of 6 are 1, 6, 2, and 3. Invariably, factor simply means find any two values that you will multiply to get that particular number. That's what factors are. So factors, when we look for factors of a number, we are looking for two values. Two values we will multiply. Two values we will multiply to get the number. Two values we will multiply to get the number. So the idea of factors have now been well understood. Now, in the case of quadratic expressions, we are not going to be given a number. We are going to be given an expression, but we will still get there. And then you are now expected to find the factors of that expression. That is exactly what we are looking at. Now, HCF. How do we find the HCF of two numbers? HCF is an acronym that stands for highest common factor. The highest common factor. Now, when we discuss HCF, it means, for instance, you are going to be given two numbers. Let's consider two numbers. Consider two numbers given. The two numbers are 6 and 12. And you are asked to find the HCF of 6 and 12. Now, what HCF means is there is a factor, which is a number, a value, that will divide 6 and also divide 12 at the same time without a remainder. Now, you see that there are many values that can divide 6 and 12 at the same time. Take, for instance, 1 can divide 6 and 12. Good. So, 1 is a common factor between them. Now, let's also think about other numbers that can divide 6 and 12. 2 can also divide 6 and 12 at the same time. So, 2 is a common factor between them. Let's also think, I know you're thinking with me, 3 is also a common factor because 3 can go into 6 and also go into 12. Let's go through again. Now, 4 is not a common factor because 4 will give us a remainder here and then 4 can divide this directly. So, 4 is not a common factor. Then, 5, let's check again, 6. 6 is a common factor. 6 can go into 6 and 6 can also go into 12. So, I don't think there's any other number that can go into both of them because once the number is now bigger than 6, it can no longer go into the. So, these are called common factors of 6 and 12. Common factors of 6 and 12. Now, among these common factors, notice something very important. This 6 here is the highest one. So, since this 6 here is the highest one, we call this one the HCF. So, what is the HCF? HCF is simply the biggest common factor among the common factors of 2 or more numbers. The biggest one among them. So, once you find the common factors of 2 numbers, just pick out the biggest one. That biggest one, or the greatest one rather, is called the HCF. Why did we bring in HCF in our outline here? Because it's going to be very useful. And sometimes many students don't even know how to find the HCF. That's why we have highlighted it and brought it into our objective as well. So we are going to quickly look at how to find the HCF of numbers. How do we find the HCF? Because it's very important that we know how to find HCF. So when we are given 2 numbers, 6 and 12, finding the HCF, I quickly tell students, it's very easy to find HCF. It's very easy. Find the primes of each number given to you. The primes are 2 can go in here, 3 can go in here, 1. 2 can go in here, 6, 2 can go in here, 3 can go in here, 1. Now find the common primes they have in common. Their primes they have in common. 2 is here and then 3 is here. From each common prime, just pick one. So I'm picking 2 from here, I'm picking 3 from here. Our HCF here is 2 times 3. Find the product of those common primes. We have 6. So that's just a simple way of finding the HCF of 2 numbers. Now, the same process we have done here is what we are going to also apply when we get into algebraic expressions. We have just been dealing with numbers. So to understand clearly how to find the HCF of algebraic expressions, the foundation that must be laid is on how to find the HCF of numbers. So we've been able to explain what factors are. This is done. We've been able to explain how to find the HCF of 2 numbers. Very, very important. We're going into the second objective now, which is meaning of factorization. Meaning of factorization. I hope we're all together. Okay. So factorization is a word that is coined from factors. This came from factors. It's a word that is coined from factors. Now, what is factorization? It's a process of separating an expression into factors. Simple. Once you are able to separate an expression into factors, you are said to have factorized it. Very simple. There's no other way to explain what factorization means. So, which means separating, take note of these factors now, an expression into factors simply means finding those 2 things you will multiply to get the expression. It's as simple as that. Or finding 2 values or expressions or entities, let's use entities, we will multiply to get the expression. Finding 2 we'll multiply to get the expression, So it's just as simple as that. There's no need wasting time here. That's the meaning of factorization. Once you have reduced or broken down an expression, separated them into factors, it is said that you have factorized it. So the question now is, how do we separate an expression into factors? If we were talking about numbers, it's very easy. Take for instance 6. How do we separate 6 into factors? By finding two things you multiply to get 6. So those things we multiply together to get a particular number, those things are called factors. It's as simple as that. Okay, so we've been able to explain what factorization means. Because we are getting into how to solve factorization method, it becomes important that we also review the general form of quadratic equation. I gave you that form in our last class. I don't know who can still remember the general form of a quadratic equation. Anybody? You're thinking now? Okay, I'll help you. The general form of a quadratic equation, or an expression rather, is ax squared plus bx plus c. Let's work with an expression. Remember, an expression will not carry the equality symbol. But if we want to convert this to an equation, it means I'm going to introduce the equality symbol and then write 0. But let's move with the expression only. Okay, so this is how the quadratic expression looks like. We needed to make a review of it. Very important. So which means, if I give you x squared plus 4x, or let's work with this, plus 5x plus 6, this is an expression. This is an expression. It doesn't have an equal symbol. Now, somebody will begin to ask a question. We go into the next one. They say, how do we obtain a quadratic equation? Now, 6. Somebody will ask you, how do you obtain 6? By finding two values you multiply to get 6. 2 times 3 is 6. 1 times 6 is 6. So these things are called factors. But we are not going to be given a number. We will now be given a quadratic expression. And we are asked to factorize. That is, find the factors. The two things you will multiply to get this quadratic expression. Once you find those things you multiply to get a quadratic equation, you have factorized it. So our job is cut out. Very simple. How to find the factors of this. Those two things will multiply to get a quadratic equation. And that is exactly what has led us to this now. Now, how is a quadratic equation obtained? Very simply put, watch how to obtain a quadratic equation. A quadratic equation is obtained by multiplying. Please take note of this. By multiplying two binomials together. Please take note of this. By multiplying two binomials together. Now, in our previous videos, I had explained what a binomial is. I said that a binomial is an expression that has two terms. A binomial has two terms. That is to say, if I have x plus 2, this is a binomial. And then I also have x plus 3, this is also a binomial. So, when you multiply two binomials together, you are going to get what we call a quadratic expression. Very easy. Now, which means if you are asked to factor out a quadratic expression, the factors you are going to get are going to be two binomials. Very important. Now, let's try to multiply these binomials and see whether it's going to give us a quadratic expression. Let's go through that immediately. Okay, so they said to get a quadratic expression, we need to multiply two binomials. That is to say, if I have x plus 2 and I have x plus 3, if we multiply this together, it should give us a quadratic expression. So let's work it out. Don't forget, I also gave you a simple method on how to multiply out binomials. We use the FOIL method. The first terms. This is first term. This is first term. X times x. Outer terms, the ones at the extreme. This is at the extreme times. This is at the extreme plus 3. Inner terms, the ones inside, plus 2 times x. And then last terms, the last ones, plus 2 times plus 3. We work it out now. X times x will give you x squared. X times plus 3 will give you plus 3x. Plus 2 times x will give you plus 2x. Plus times plus is plus 2 times 3 is 6. The ones in the middle are referred to as like terms. So this is going to give us 5x. Now you can see we put them together. We have x squared plus 5x plus 6. Something has happened here now. If you observe close, you see that we have multiplied these two things here. And we have gotten what we call a quadratic expression. I know so many persons have been wondering, I already knew that these are going to give me the factors. But now our job is now going to be, when we are given this, how do we get back this? Because we refer to this as factors of, these are called the factors of this quadratic expression. Now, our job is how to get this when we are given this. And that is exactly what we are going to dwell on today. But I've tried to establish a fact here. And what is that fact? If you want to obtain a quadratic expression, you must multiply two binomials. Now, when you are now given a quadratic expression, to bring those things you should multiply to get them, the process is called factorization method. And we are going to learn how to do that. So we are done with this. I've explained the process of factorization. We are going into types of factorization immediately. There are basically two types of factorization. We have two types of factorization. Quickly, two types of factorization. The first one is factorization by common factors. Factorization by common factors. And the second one is called factorization by grouping. Very simply, factorization by grouping. Okay, I hope we are together. We're going to talk about this. So what is factorization by common factors? Very simply put, pay attention. Factorization by common factors simply means factorization by CF simply means bringing out the HCF. Take for instance, I have 5x plus 10. Somebody can ask you, factorize this. Now, if you look at the terms in this expression, you see that there is something common between this and this. Bringing out that thing that is common, which is the HCF, that's why we talked about HCF earlier, is what we call factorization by common factors. Bring out their common factors. And that common factor you expected to bring out is called HCF. Now, if you look at this and this, you see that the highest common factor between 5x and 10 is 5. The HCF here is 5. So, if you bring out this 5, the process of factoring out what is left is use this, divide by that HCF, plus 10, divide by that HCF. You see that 5 will cancel 5. 5 into 10 is 2, and you are left with 5 bracket x plus 2. I have factorized this. So we call the process of bringing out HCF and then dividing all the terms by that HCF the factorization by common factors. If you multiply this out now, you see that you will get back 5x plus 10. So I have reduced 5x plus 10 to its factors. And what are the factors of 5x plus 10? The factors of 5x plus 10 are 5 and x plus 2. So these are the factors. If you multiply these two things together, you get back 5x plus 10. So this is just about how to factorize by common factors. Okay, now we're going to now dwell on factorization by grouping, and that is where we're going to focus today on, because that's where we're going to apply factorization of quadratic expressions. Okay, so what does factorization by grouping now mean? What does factorization by grouping mean? Factorization by grouping usually comes in when there is no longer HCF between the terms in an algebraic expression. Take for instance, we found HCF here, but there are things to be given. Take for instance, let's take for instance, x squared plus 2x plus 3x plus 6. If you look at this now, you see that there is no HCF in this expression. That is, nothing can divide everything here at the same time without a remainder. We can't find anything. There's no HCF here. So grouping comes in, grouping, when there is no HCF. And what does grouping mean? Grouping simply means we are going to arrange this in pairs. Pairs means 2, 2. So we're going to arrange it in pairs and then apply what we call factorization by common factor. So in factorization by grouping, we arrange in pairs. Please take note of this. We arrange in pairs and then use factorization by common factors. It's just as simple as that. Okay, let's change this. Change this quickly. So I hope we are following up. We're almost there. We're almost there. So let's get through. Almost there. So we'll just take an example. Take for instance an example now. Factorize x squared plus 2x plus 3x plus 6. What is the process of doing this? There's a stepwise approach of using factorization by grouping. I tell students, please focus on this, everybody, because this is the area where many students always find it confusing. Separate them in pairs. This and this are 2. Just draw a line like I tell my students to do. Find the HCF between these 2. You use each pair, you factorize by common factors. And if you look at this critically, you see that only x is common between this and this. X is common. If you find the HCF, you see that x is there. Bring out that x. Use this x and divide this. X into x squared will drop you 1x plus x into 2x. It will cancel x and drop 2 for you. So you are done with this. I tell students, to get what is going to be here, please don't write any sign. Just open a bracket for me. Then write down the HCF here. HCF between 3x and 6. You see that 3 can go into here and 3 can also go into here. So 3 is the HCF. Write down that 3. Write it down. Now, the next step, we follow steps in factoring by grouping. You see this thing you have written here. Carry it and bring it into this bracket. Factorization by grouping says that what you have in the bracket must be the same. So carry this thing here, bring it into this bracket. It must be the same. Now let me move this. X plus 2. There is a sign that is going to be here. I tell my students, do not bother about what sign to put here. I will give you a trick on how to find the sign that you put here. Go and check. Compare these two signs you have here. If this sign is the same as you have here, please go and put plus here. If this sign and this sign are different, just go and put minus here. Please take note of that trick. So you group the ones outside. What do we have outside? X plus 3 bracket. What do we have inside? Is the same. X plus 2. We have factorized this. We will take another example to buttress what I've just said now. We'll take another example. I guess you will understand what is happening now. Okay, example 2. Factorize. Let's factorize x squared minus 4x plus 3x minus 12. Now recall what I said. Follow your steps. Follow your steps. I've just detailed the steps on how to factorize by grouping. Follow your steps. What do we do? Draw a line. Find the HCF for this pair. We have already paired them. This 2 and 2. So I'm going to have that x is my HCF. X divided by this, it will drop 1x. Write down your sign. X into x will drop 4. Now do not run along and put a sign here. Remember I said just draw a bracket for me and then find the HCF between these two. And the HCF is 3. 3 can go into this. 3 can also go into this. Write down your 3 immediately. Don't waste time. Carry this and bring here. What is in this bracket? I have x minus 4. Obviously, because that's exactly what you're going to have here. How do I know? If you use this 3 and divide this, x will drop. 3 divided by 12, 4 will also drop here. You can also do your division, just like we have done in this case. No issues at all. Then ask yourself, you will notice that this minus is still the same minus here. It didn't change. We are going to insert plus there. And what is our answer? X plus 3 bracket x minus 4. So we have factorize this quadratic expression. Now, the trick now comes. See where the trick now comes. They will not give you a quadratic equation that has 4 terms. I have made it simple for you here by giving you the one with 4 terms. They will now give you a quadratic equation the way it should be. Take for instance, this is how they will give it to you. X squared plus 5x plus 6 and say factorize. Now you see people saying, sir, but this one has 3 terms. If I can't pair them, I can't bring them into pair. And that is where the problem comes. And I'll try to dissolve that immediately. It means we will get into this. If you are given a quadratic expression in the general form, you will do everything possible to reduce it and break it into 4 terms so that you can break into pairs. At the level where we are today, we're going to stop, and in our next class, we are going to learn. We've already talked about factorization by grouping. We've looked at the steps of factoring. We have not looked at this, and this is where we are going into our next class so that people can also take their time and understand, digest all what we have done today. So in our next class, take note, we're going to learn how to break a quadratic expression in its general form into 4 terms so that we'll be able to use factorization by grouping. I want to believe you enjoyed the methods we have done this evening, and no doubt you're going to practice questions on your own. Feel very free. Please like, comment, and share. Our maths videos are now more circulated on our YouTube channel, so make sure you check up on the YouTube channel or any other platform for the videos. Watch, share, like, comment, so that we'll have a good fan base watching our videos. Thank you for watching, and God bless you.